there's neurons there's cells up in your brain, and there's cells in your spinal cord. And they communicate with each other by sending signals, electric signals, along these cables called axons. And after an injury, those axons get cut and it blocks the communication. The motor signals can't get down, so you're paralyzed. The sensation signals can't get up, so you can't feel. And labs across the globe, including my own, are working on this very basic problem. How can we get those cables to regrow? And how can we get them to connect to the right place? Most of our budget comes from large federal grants. It's how we survive. And those are hard to get. Those are really hard to get. Right now the success rate is 8%. And the problem is, because the money is scarce and because it's the federal government, there's this bias towards safe science. You can't go to the federal government and say, hey, I've got a great idea. Can I please have some money? It doesn't work like that. You go with a great idea and a lot of preliminary data, a lot of experiments to prove that you're on the right track. The fact is, a lot of science needs to progress that way. We need that steady incremental progress. But there is this problem, right? Because alongside that steady progress, you need leaps. You need to jump forward. You need to innovate, okay? And that's where the system tends to break down. What if you could get people together? What if you could pool money, little from here, little from here, little from here, and you could make this pool of money, and you could make spinal cord researchers compete for it? That's key. They have to compete for it, and they do. But what if you gave them a little bit more latitude? What if you let them get just a little bit farther in front of their data? What if they could take their idea, do that first experiment, and then leverage it to get the big federal grants? And it works. It works fantastic. I've seen it work in lab after lab. It's worked in my own lab, right? We took a $50,000 pilot grant, we turned it into a $500,000 federal grant, and now we're transitioning that to a bigger federal grant.
What's happening now is that people are finding out that the spinal cord is more receptive to plasticity than people had thought before. And so there are a lot of projects, and many of these are funded through MCPF, which is what's really great about it. And it's across the world. There's grants that I've reviewed from France, from England, and other places. And what they're doing is figuring out ways to have the brain talk to the spinal cord below the level of the injury. Without this kind of funding mechanism, you're not going to see these types of projects that are actually pushing the envelope.
What MCPF does for me as a young adult is they're so passionate about the research and so passionate about funding those who don't have enough to do it themselves. It's that sort of STEM research and that STEM funding, giving a chance to someone who doesn't have one, that speaks really well to me, and I assume my demographic. I think younger people want to cheer for the underdog and support those who really need the support.
Yes, the money that you're giving to the Morton Fund lets us do experiments, innovative experiments, that we could never do otherwise. That's true. But it's also true that because we know it's there as a possibility, it fosters creativity, it fosters innovation, it lets us explore. And when scientists can see possibility, that means hope today for people that suffer from spinal cord injury. And as those possibilities turn into realities, it means tangible progress in the future.